So for this question, if you want to find out what is the draw the potential energy, right? Now remember, they already drew for you what? The CAIE, right? So some of the things that you must be careful, right? Since this is an energy versus displacement, so this represents the amplitude, right? You see that? Because energy versus displacement. So therefore, you must make sure that when you draw the PE graph, don't exceed this value. That means this is your amplitude. So this is your maximum. So how do I know what is the maximum value? Can you see this maximum KE? It must be the same as your maximum PE. So the amplitude also must be the same. Maximum energy must be the same. So 1 point here. And then the PE at the middle is 0. The PE at the other end is maximum also. So negative. Amplitude is 5 centimeters. So negative 5 centimeters, same point. Must be same. Also maximum energy. So another point here. Then you draw this. Okay? So ignore this first. This is nothing to do with this answer yet. This one comes later. Okay, so just draw this and label potential energy. Now for the next part, the total energy easy lah. It's just a straight line, must be the same as your maximum KE. So make sure you draw this straight line, but don't be too enthusiastic and draw it until here or here. You must stop at the amplitude here. You must stop at the amplitude here. So this horizontal line must stop here. Stop here. Alright, that's all. Now for the next part, if you want to find the angular frequency of the vibrations, now remember I told you angular frequency omega, the fastest way to find, of course, is to use 2 pi f or 2 pi over period. But the question is, do you know the period and frequency from this graph now? You cannot get period of frequency because this is energy versus displacement. There's no time at all. But you can find the omega, all right, from the value of the maximum energy. Because you know why? The total energy is half m omega squared x naught squared. Remember I told you to memorize this? But you can't, you can always derive this. Now you can get the total energy from this graph, which is the maximum KE by the way. Now read the graph, your maximum KE will be 15 millijoules. You don't believe, you go back and try yourself. But you can count the number of boxes now. So how I count number of boxes? Now from the highest point to down there, to the peak, right? Can you see it's 2.5 boxes? Means from the highest point, you go down, can you see it's 2.5 boxes to the peak? So one box is 4 milli, from here to here, 10 boxes is 4 millijoule. One box is 0.4 millijoules. So 2.5 is 1 millijoule. Correct now, 0.4 plus 0.4 plus 0.2. So 1 millijoule difference. So 16 minus 1 millijoule is 15 millijoules. So 15 millijoules is half m omega squared x naught squared. So refer to your question, mass was given. Now x naught represents amplitude. Now that you can obtain from the graph because this is your amplitude. So can you see amplitude is 5 centimeters? So substitute 5 centimeter here. Don't forget to change it to meter because radian per second is SI. This has to be SI. Okay, and then put the square there because x naught squared, and then you should be able to find your omega as 8.94. So the next part is they told you the oscillations are subject to damping. So what is meant by damping? That one you can refer to your notes on this definition. But the one we discuss is this part 2. The mass loses 20% of its vibrational energy. Determine the new amplitude. Explain your working. Now remember I told you in your structure paper, whether it's paper 2 or paper 4, explain your working means you need some kind of a statement before you start. So in this case, there are 2 ways of solving it. One from calculation, one from graph directly. So I'll show you both ways. If you're calculating, your total energy is how much now? Originally is 15 millijoules. If you lose 20%, what is your new total energy? How do I calculate the new total energy? 80% times 15, right? That's our 12 millijoules. So if you are using that method, you can say that the total energy is now 12 millijoules. That is your explain your working part. You need to put that statement. The total energy is now 12 millijoules. Okay, write that down first. Okay, now, after you have written that down, assuming you want to calculate your new amplitude, because your total energy drop means definitely your amplitude will drop. So how do I find the amplitude? Now, you use this, 12 millijoules, so you use 12 millijoules equals to half m omega squared x naught squared. Now, the assumption we are going to make is the omega remains constant. Now, we all know, right, actually, when there's higher damping, it will move slower, right? And if it moves slower, the period is supposed to get longer. So if the period gets longer, so your omega is 2 pi over period, the omega should get smaller, right? But for the sake of calculation, you don't have to show the change in frequency or period. So omega is the same, because it's a very small change in it, so we assume it's negligible. So the omega is constant, so you can use back the same omega. So some people do the long way, so they substitute the m and the omega from the previous part, same value, then they find the x naught. If you don't want to do that, you can use ratio because your total energy is half m omega squared x naught squared. Half m omega squared is going to be constant anyway, so your total energy, the new one, E2, over the original total energy will be the ratio of x2 squared over x1 squared. You can do that, two ways also can do . So substitute your new total energy with 0.8 E. So this way, I don't even have to calculate the total energy is how much. Over the original total equals to your new amplitude squared over your original amplitude squared. Then you can get the answer. If you don't want, go ahead. Substitute your m and omega from the previous part and find your x naught. Also can, up to you . So these two methods, not a problem, because it's just calculation. But there are many times in the exam, right, where they don't give you any space for calculation. You can actually get the answer, the new amplitude, without using the value of all this calculation. How do you do that? I teach you the technique. If you're going to lose 20%, that means you're going to lose how much? 20% of 15 millijoules is 3 millijoules. So basically what it means, now remember, we can always use the graph to get the new amplitude. Now how? Now the graph they gave me was this. The graph I drew with this. But of course what they gave me is always going to be more accurate than what I drew right now. So I'm going to make use of their graph. So imagine this is my original CAIE graph. My total energy is 15, but I'm now going to lose 3 millijoules. So that means this graph here must shrink by 3 millijoules. So I'm going to cut off 3 millijoules from this graph, you understand? But which part do I cut? From the top or from the bottom? Because I drew . Okay. Now why cannot cut 3 millijoules? Because some people say, we can't count 3 millijoules here and cut off . If I count 3 millijoules from the top and cut off, that means my graph got no head already. Correct not? But if I measure 3 millijoules, got to cut off 3 millijoules, that means I shift my horizontal axis up by 3 millijoules. Isn't this 12? So this is my new graph with 12 millijoules. So if this is my new graph, this is my new horizontal axis, where it cuts the horizontal axis, is this my new amplitude? So you count 3 millijoules here, you draw a straight line. You notice it intersects here, you read the graph. You get 4.5 centimeters exact, without having to calculate the amplitude.
That's all for today's video. If you are interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.